back to our Mastermind program here. We've got our pseudocode written. We're ready to start filling in the components of this program. So at the beginning, we're going to need some random numbers. So make sure that you are including your time library, time.h. And then what we'll do is we'll start writing things underneath the example section here. So let's get our randomization out of the way right at the beginning. So srand time null, and that'll help that portion work. Okay, so in this part, what we're going to do is we're going to set the solution code and write our variables. So in the section of variables, we can go through the pseudocode and determine what variables we'll need for every component. So the first thing is, for the solution, we are going to need the 4 individual positions for the solution. So 1, 2, 3, 4, we would need a variable to represent each of those. So we're going to call them position 1, position 2, position 3, and position 4. So this is going to represent, so we'll add comments just to clarify what all the different variables are for in this program. So this is going to be the solution positions, I guess digits we'll call this, by position. So we use the word positions 1, 2, 3, 4 to determine which order they are in. And then what we're going to do is we'll have a difficulty set. So the difficulty level for this is going to represent how many digits are possible. So we'll start with const int max, which is going to be 6. So the maximum digit we're going to have is 6. We're going to get random numbers from 1 to 6. So this is the maximum digit allowed. There we go. And then what the user is going to type in is, when we prompt them, we are going to need a guess. So this will be the user's guess. And what we're going to do is we'll use a Boolean variable to verify whether their guess is a valid guess or is an invalid guess. So we'll go bool is valid, which is my usual term for this. So this is whether guess is valid. Now, what we're going to do is after we check to see that it's valid and as some component of the guess, we're also going to have to break the guess into the individual position digits from that guess. So it's going to be G position 1, G position 2, G position 3, and G position 4. So this is going to be the digits from the guess. Okay. Now what we'll do is, in the solution, we will say how many digits they have correct, and then how many digits are actually in the correct position. So what we're going to do with that is we'll call digits, and we're going to set this to 0 because we'll have to kind of keep checking this. So this is how many are in the wrong place. And then int position, this is going to be how many are in the correct place. And then we're ready to get started. So again, what we want to do in this phase of creating the program is we want to set the secret solution. So what we're going to start with is our position 1 is going to be equal to random modulus max plus 1. So this way, if we want to increase the difficulty, we can increase the max value above 6 and then have 8 different digits that will be allowed. So our position 1 is going to be like this, and I'm going to copy and paste this for the others. So this is going to be 2, and then this is going to be 3, and this one's going to be 4. So we've got everyone set correctly here. But now what we want to do is, this doesn't totally work because potentially we could get a code that would be 2222. And one of the components of Mastermind is typically there are no repeating digits in the solution code. So what we have to do is we have to make sure that when we're done with the solution here, we want to make sure that none of the digits are the same as any other digit. So what we want to do is we want to just very simply, we're going to use the power of looping to make sure that that is the case. So we'll start with a do here. And I'll tab these 4 lines in. And then we will pick a while for this. Now, this is going to be a really long while condition. Because what we want to do is, again, think of this as an if statement. If this is the case, then I want you to loop. So what I want to do is I want to loop this if any of the digits are not unique. The easier way to write this is we want to loop this if any of the digits is the same as any of the other digits. So all we have to do is we have to write every combination here. So position, what we want to do is we want to loop this if position 1 is the same as position 2. So if it would be 1, 1, 3, 4, then it would loop. But we also want to check every other position as a possibility. So we want to loop it if that's the case, but we also want to loop it if position 1 is equal to position 3. Put an or here because we also want to loop this if position 1 is equal to position 4. Now, there's other things that we have to check here. Or we're going to loop this if position 2 is equal to position 3. We don't have to check to see if position 2 is equal to position 1 because we've already got that handled by our very first conditional statement here. And then, or we want to loop again if position 2 is equal to position 4. And the only thing that we haven't checked yet is to see if position 3 is equal to position 4. And there we go. So what that's going to do is if any of the digits are the same, what it's going to do is it's going to loop again until it finds that they are correct. So just to show you that, and we're going to be removing this line just before we actually create the remainder of the program. Inside the loop, we'll do a cout position 1, position 2, position 3, position 4. And we'll do an end L here. So obviously in the final version of the program, we don't want to display to the user what the secret code is, because that'll ruin the fun, but this will show us what the loop is doing. So I want you to run this program a couple of times and we'll see how effective it is. So take a look at the first one here. We've got 1, 4, 5, 1. So the 1 and 1 are identical, so it's going to loop. Then 1, 5, 5, 4, so it's going to loop. 3, 5, 5, 4, it's going to loop. 5, 5, 1, 5, so there's 3 digits that are matching, and then it gets down to 2, 4, 6, 5. And then it's satisfactory, and then it would continue on with the remainder of the program. Let's run it a couple times just to kind of see how this is going to go. So occasionally it will get the correct solution on the very first try. We got 2 like that. There we go. It takes 4 tries again in order to get that right. So anyway, save your program before moving on to the next stage, and then we'll be ready to go with checking to see if their guess is valid, and then also giving them a clue to tell them how good their guess was.